Section 4.2, trigonometric functions, specifically the unit circle. So our objectives, the first is to fill out the unit circle from memory, but that one might be a little more challenging considering how the end of last year happened. We're also going to evaluate trig functions using the unit circle, and we're going to identify the domain and range of sine and cosine. So first, let's consider the unit circle, where the equation is x squared plus y squared equals 1. In general, for the equation for a circle, the equation is x squared plus y squared equals r squared. So it's like r squared in this case is 1, which means it has a radius of 1. If you draw somewhere, I'm just going to draw it in quadrant 1, a radius that's got a radius of 1. And if you're to make this into a right triangle, the horizontal leg would have a length of x, the vertical leg would have a length of y. Now, thinking back to what you learned about sine, cosine, and tangent, you might have to think all the way back to geometry if you didn't have a chance to cover it last year in Algebra 2. Sine is the opposite over the opposite over the hypotenuse. So if this is angle theta here, the opposite side, let me zoom in, the opposite side would be y and the hypotenuse would be 1. So it's going to be y over 1. Cosine would be the adjacent side, so the leg that it's touching over the hypotenuse would be x over 1. The tangent is opposite over adjacent, so that would be the opposite side y over the adjacent side x. Now there are 3 more functions, and again, if you didn't have a chance to cover this in Algebra 2 last year, you might not be as familiar with these, but I believe you did them in geometry a little bit. They are cosecant, CSC, secant, SEC, and cotangent, COT. Now, I have these lined up the way that I do because they're very closely related to the ones that they're lined up with. Cosecant is related to sine in that it's the reciprocal of sine. So if sine is y over 1, cosecant is going to be 1 over y. For secant, it's the reciprocal of cosecant. So instead of x over 1, it's going to be 1 over x. And then for cotangent, instead of y over x, it's going to be the reciprocal x over y. Next up, it's asking us to fill out the unit circle, and it says at the back of the packet, but I'm actually have this as a separate document. So, let me pause the video, and we'll pick that up in the next page. So here's the unit circle. Now, if you didn't see this at all last year, it's pretty intimidating, but we're going to try to keep it as simple as possible. So we're going to start off with the angle measures in degrees, and the degrees we're starting off with over here on the positive x-axis at 0 degrees. Then we're going to move our way up 30 degrees, 45 degrees, 60 degrees, and 90 degrees. We kind of referenced these a little bit in section 1. Keep going from there. Notice the pattern here for angle measures. This size angle is a 30-degree angle, so the next angle measure is going to be 30 degrees more than 90. It's going to be 120. Next up is going to be 135, then 150, and then half a circle is 180 degrees. So again, kind of emphasizing what I was saying a second ago. The larger gaps, if you want to think about it as like slices of pizza or slices of pie, those measure 30 degrees, and the smaller pieces are 15 degrees. So every big jump is 30 degrees, every small jump is 15 degrees, sorry. Next up, we're going to go another 30 degrees, so 180 plus 30 is 210, plus 15 more is 225, plus 15 more is 240, plus 30 more is 270 degrees. Keeping around the circle, we got 30 more degrees, we're at 300 degrees, 315, 330, and now we've completed a full circle of 360 degrees. So now we have the angle measures in degrees, but let's go for it in radians as well. Now, a couple key things. I want to go back to the beginning. 0 degrees is the same as 0 radians. 180 degrees is pi radians, and then 360 degrees is 2 pi radians. I'm going to kind of base everything off of pi being equal to 180 degrees. Now, we've done a couple of these angles before, but just kind of putting it in that perspective. So if pi is 180 degrees, 30 degrees is 1/6 of that, so that's going to be pi over 6. 45 degrees is 1/4 of 180, so 45 degrees is going to be pi over 4. Oh, not pi over pi, pi over 4. 60 degrees is 1/3 of 180, so it's going to be that 1/3 of pi, or pi over 3. And 90 degrees is half of 180, so it's going to be half of pi, or in other words, pi over 2. Everything else is going to be based off of that. So 120, you can think about that as 2/3 of pi, or it's like, well, it's 2 times larger than 60 degrees, so it's going to be 2 times pi over 3. 135 is 3 times larger than 45 degrees, so it's going to be 3 times pi over 4. In other words, 3 pi over 4. 150 degrees, that's like the same as 30 degrees times times 5. So it's going to be 5 times the pi over 6. And again, now we're at pi being 180 degrees. 210, thinking back to quadrant 1, that's like 7 times larger than 30 degrees. So it's going to be 7 times larger than pi over 6. So it's going to be 7 pi over 6. 225, that is 5 times larger than 45, so it's going to be 5 times larger than 5 or than pi over 4, so we got 5 pi over 4. 240 degrees, that's 4 times larger than 60 degrees, so it's going to be 4 times pi over 3, 4 pi over 3. 270 is 3 times 90 degrees, so it's going to be 3 times pi over 2, in other words, 3 pi over 2. 300 degrees, that's 5 times larger than 60 degrees, so it's going to be 5 times that pi over 3. 315 degrees is 7 times larger than 45 degrees, so it's going to be 7 times that pi over 4, so 7 pi over 4. 330 degrees is 11 times 30 degrees, so it's 11 times pi over 3, so 11 pi over 3. And now we're back to the full circle. Okay, next up are the x and y coordinates. I'm going to kind of break this down a second. So in quadrant 1, 0, 0, or sorry, not 0, 0, the coordinate or the angle measure 0 degrees or 0 radians has an x coordinate of 1 and a y coordinate of 0 because it has a radius of 1 going from the center out to that point straight along the x-axis has a radius of 1. So its x coordinate is going to be 1. It's not going up or down. Let's fill in some other key points. 90 degrees is going to be 0, 1 because it's 0 on the x-axis, 1 on the y-axis. 180 degrees, that's 1 to the left, so that's going to be negative 1, 0. 270 degrees is going to be 0, negative 1. Now for the x and y coordinates, I actually want to go back to the actual note page. Going back to the note page, you'll notice it says the sine is y over 1 and the cosine is x over 1. In other words, the sine of the angle is going to be the y value, the cosine of the angle is going to be the x value. So with this first quadrant, we've got 30 degrees, 45 degrees, and 60 degrees. I want to focus just on the 30 and the 60 for a second because they're very closely related. If we draw a right triangle, and I'm going to call it a 30, 60, 90 triangle. So this would be 30 degrees. This would be 60 degrees. We call the short side x. The hypotenuse would have a length of 2x. And the longer, would have the length of x times the square root of 3. Now, thinking about the x and y coordinates, again, going back to the previous thing I just said, the x coordinate is the cosine of the angle. The y coordinate is the sine of the angle. Now, the cosine of the angle is going to be the adjacent side to 30, which is the square or x over the square root of 3, divided by 2x. Well, the x's are going to cancel out, and we're just going to be left with the square root of 3 over 2. Now, for the sine, it's going to be x over 2x, the opposite side, that bottom side over 2x. And the x are going to cancel out, so we're going to be left with just 1 over 2. Now, for 60 degrees is a little different, but it's really, really closely related. The cosine is going to be the adjacent side, which is x, over the hypotenuse of 2x. So it's going to be x over 2x, which would be 1 over 2. And then the sine would be the opposite side, so that's square root of 3 x times the square root of 3 divided by 2x. So the x's again are going to cancel out and just be the square root of 3 over 2. So the sine and cosine of 30 and 60 degrees are kind of opposites of each other. The cosine of 30 degrees is root 3 over 2. The sine of 60 degrees is root 3 over 2. The sine of 30 degrees is 1/2. The cosine of 60 degrees is 1/2. Now for 45 degrees, I'm going to draw a 45, 45, 90 triangle. So if this is 45 degrees, this is a right angle, this is another 45 degrees. The short legs would be x, and the hypotenuse would be the square root of 2 times x, or x times the square root of 2. Let me zoom in a little bit. So if we're doing the sine of that angle, sine of 45 degrees, it'd be, well, it doesn't really make a difference. It'd be x over the square root of 2. Now the reason I'm doing this a little more specifically here is because, x over x times the square root of 2. The x's cancel out, we're left with 1 over the square root of 2. Now if you think back to what we've done in the past with simplifying fractions, and especially dealing with eliminating radicals, we'd have to multiply the numerator and denominator by the square root of 2, which would give us the square root of 2 over, well, square root of 2 times itself is just 2. So the sine of 45 degrees is the square root of 2 over 2. Let's fill that in. So that's our y coordinate. Now cosine, you could do the exact same thing and you're going to end up with the square root of 2 over 2. Folks, before we go any further, I want to emphasize quadrant 1 is the quadrant you're going to want to memorize. Everything else you can kind of relate to quadrant 1. Speaking of which, quadrant 2, taking a look at this, well, quadrant 2 is really just a mirror image of quadrant 1. The y values, the heights of all those points are the same as they were in quadrant 1, but all the x coordinates have been reflected over. So I'm going to zoom in a little bit. This might get a little dizzying for a second. But at 60 degrees, in other words, pi over 3, we have the coordinates 1/2 root 3 over 2. Over here at 120 degrees, with 2 pi over 3, we're at the same height. The y coordinate is going to be still the square root of 3 over 2. Now the x coordinate, it's the same distance away from the y-axis as the other one. So the at 60 degrees is 1/2 away. At 120 degrees, it's going to be 1/2 away, but in the left direction. So it's going to be -1 over 2. Similarly, for 135 degrees, it's going to be negative square root of 3 over 2. Sorry, goodness gracious, not square root of 3 over 2. Negative root 2 over 2. Positive root 2 over 2 for the y coordinate. For 150 degrees, that's 30 degrees reflected over, so it's going to be negative root 3 over 2, and then positive 1/2. And then the 180 is the reflection of 0 degrees, so we already have that, it's -1, 0. Before we go any further, observing patterns here, x and y coordinates in quadrant 1 are both positive, so it's positive, positive. In quadrant 2, the x coordinate is negative, the y coordinate is positive. Quadrant 3, they're both negative. So we're going to say negative, negative. So those are also going to be mirror images. We're going to take the mirror image of 150 and reflect it over, and that's going to get a mirror image down here at 210. So the x coordinate is still going to be negative root 3 over 2. And now the y coordinate is also going to be negative, -1/2. I'll zoom in a little bit. 225 degrees is going to be the reflection of 135, so it's going to be negative root 2 over 2. And then the y coordinate is also going to be negative root 2 over 2. For 240 degrees, that's 120 degrees reflected over, so we have a -1/2, just like we did it for the 120 degrees. But now the y coordinate is going to be negative root 3 over 2. And then we already have 270 degrees, but again, following that pattern, it's 90 degrees reflected over. Now, quadrant 3, we're going to have a positive x coordinate again, and a negative y coordinate. So you're going to reflect, well, really whatever ones you want. I'm just going to go back to quadrant 1. I'm going to take 60 degrees, and I'm going to zoom in a lot, sorry. We're going to take 60 degrees reflected over to give us the 300 degrees. So the x coordinate is still going to be positive 1/2. So we got 1/2 down here. And the y coordinate is going to be negative square root of 3 over 2. So it's just the reflected version of 60 degrees. 315 degrees is going to be the reflected version of 45 degrees. So it's going to be positive root 2 over 2 because we're in the quadrant 4 with a positive x value. And the y value is negative root 2 over 2. 330 degrees is 30 degrees reflected over. So the x coordinate is root 3 over 2. The y coordinate is going to be -1/2. Folks, there are a lot of patterns that you can observe here. I want you to spend some time looking at this, seeing what patterns you might find yourself.